All right, guys, let's do number 59. A skier leaves the ramp of a ski jump with an initial velocity of 10 meters per second at 15 degrees above the horizontal. So let's draw this. All right. So this guy leaves at the initial velocity at some v naught, and that v naught here is going to be 10 meters per second at the angle of 15 degrees, and the slope of the incline is going to be 50 degrees right here. So basically it's going to go it's going to go like this, and it's going to go land somewhere at that component. All right, so the slope of the incline is 50 degrees and air resistance. And I'll go find the distance of the ramp where the jumper lands. All right, so this is going to be actually pretty straightforward. In the component, the velocity component just before the landing. All right, so let's find the distance in the velocity component where it lands. Okay, so I'm going to do this, folks. Since this is going to be the angle 15 degrees, I'm going to write the motion as the r, and r is going to be x and y. Beautiful. All right, so once you have this down, your x is going to be v naught cosine of theta naught times the time. And my y, now normally I don't do this, but I'm going to make an exception here, is normally I like to call my down negative and up positive, but I'm going to reverse it just for this problem. So what I'm going to be doing is I'm going to be calling up negative. So I'm going to put b naught sine of theta naught t minus g over 2t squared. And the reason for that is because I want my y component here to represent the positive component, and my x to represent this. See what I'm doing, folks? Like a nice little trick to this. Now, we're almost done, though. So we don't know where it lands. All we're given is the angle. However, if you were perceptive, we can actually make the equation of a line. So we can just pretend that this is going to be 0, 0 depending on the y and the x. We're going to call, so this is kind of the origin here. So I'm going to put nothing more than tangent of 50 degrees times the x. Beautiful. See it, folks? So now we have your equations, unknowns. All we're going to do is take that equation, minus v naught sine of theta naught times t added to, and I forgot to put a plus. I meant to put a plus there. G over 2t squared equals tangent of 50 degrees times x, which is going to be v naught cosine of theta naught, times the time it takes. Now, we're going to use the algebra rules to solve for the time. I'm not going to do it on this video because I'm too lazy, and plus I'm way too tired to show all the work here, so I'm just going to give you the end result. And also, this is a prerequisite. You have to know your prerequisite knowledge if you're at this level of physics, guys. So, I mean, I'm not going to backtrack for you guys, and I wouldn't be able to even if I wanted to, because I suck at teaching regardless. So anyways, regardless, the time is, so once you simplify the equation, the time it takes for it to land on the ground is going to be, what is that? I did store this, is 2.87 seconds. And the nice thing about this is that we already know what x and y is. So according to this, my x, and I have this stored on my TI-84 calculator, is going to be 27.79 meters. And my y is going to be 33.12 meters. So the distance of the ramp where the jumper lands. So let's take the Pythagorean theorem. So we can answer part A. So for part A is going to be, the distance is going to be 43.24 meters. That's going to be this distance where this thing lands. So this thing will land at 43.24 meters. Beautiful, folks. I hope you find this pretty easy. Notice that this is a red problem and people are struggling with this because they don't know their basic mathematics, but really it's but I hope by watching my videos you can find that these are pretty straightforward. They're not hard. Alright, so now since we answered part A, let's answer part. Alright, so let's answer for part B. So the velocity component for V is just going to be Vx, so V cosine of theta naught. So that's going to be 9.66 meters per second. V sine of theta minus gt is going to be, and this other component is going to be minus 25.61 meters per second. Beautiful. All right, we're done.